Welcome to Spring LIB.
Hello students, the question says that the motor protein dynein moves along microtubules with a velocity of approximately 1 micron per second, and if dynein carries a vesicle with a diffusion coefficient of 10 micron square per second, is the moment of vesicle dominated by the processive motion, which is motor driven velocity, or by random motion, which is diffusion? We have to explain. So first we need to understand what is processive motion and the random motion. The processive motion is a motor driven movement of vesicle along the microtubule, while the random motion is the diffusion of the vesicle due to Brownian motion. So the given information is that dynein moves with a velocity of 1 micrometer per second, which is a processive motion, and the vesicle which carries a vesicle has a diffusion coefficient of 10 micrometer square per second, which has a random motion. And to compare the two types of motions, which is the processive motion and random motion, we have to we need to find some common parameter due to by which we can compare both of these motions or movements with each other. One such parameter is the mean square displacement, which is denoted as MST, and which is a measure of how far a particle moves on average during a given time interval. For processive motion, the mean square displacement can be calculated as is equal to the velocity time square. Since we are interested in comparing the two types of motions, we can consider MST per unit time. So MSD for processive motion per unit time will be 1 micrometer per second to the power 2, which is because velocity is 1 micrometer per second to the power 2, and which is equal to 1 micron meter square per second for processive motion. For random motion, the mean square displacement can be calculated using diffusion coefficient, which is given here, and the Einstein smallest Smolensky Smolensky coefficient, sorry, equation, which is MSD for random motion will be 4 times d times time, where d is the diffusion coefficient. So again here, like the above, we will calculate the mean square diffusion, sorry, mean square displacement per unit time, which will be 4 times diffusion coefficient here is given as 10 micron meter square per second. Since we are measuring it unit time, so time will cancel as likewise here. So it will be equal to 40 micron meter square per second. This value for random motion, it is 40 micron meter square per second. For the processive motion, it is 1 micrometer square per second. So since the MSD per unit time for random motion is 40, which is much more, way more greater than the MSD per unit time for processive motion, so we can conclude that the movement of vehicle is dominated by the random motion, which is diffusion, rather than processive motion, which is motor driven velocity. I hope you found the video useful. Thank you.